So last time we covered numbers in general and the axioms of algebra, and we went over what a rational number is. So let's just review what a rational number is. So we said last time that a rational number, say x, this denotes that it is a rational number. Q is the set of rationals. X is a rational number if x equals m over n, where m and n are in the set of integers. We always want to take m and n in lowest form, so we want 1 over 2, not 2 over 4. And as we said last time, that rational numbers satisfy those 9 axioms. So it may seem like we don't need more numbers, but we do need irrational numbers. So why do we need irrational numbers? Who can give me an example of an irrational number? Give me any irrational number. Okay, give me another one. All right, there we go. That's the one I was looking for. So why do we have pi? It comes from application. We have pi because of the circle. So say this is a circle, and this is the diameter. What's pi going to be? Pi is just the ratio of the diameter to the circumference. It's how many times the diameter will go around the circumference. So if we take a string, that's the length of a diameter, and put it around the circle, we'll cover it 3.14 times. 3.14, etc. times. So that's why we need rational numbers, irrational numbers. So what is the definition of an irrational number? We say an irrational number if it simply isn't a rational number. So x is an irrational number. This is how we denote an irrational number. X is an irrational number if x doesn't equal m over n, where mn in z is a set of integers. So that's the basic definition of an irrational number. But we also want to prove that an irrational number is an irrational number. So we know radical 2 is an irrational number. How do we prove it? So we're going to use proof by contradiction. And before we go ahead and prove it, let's do kind of a funny example of proof by contradiction. So can I erase this? Proof by contradiction. All right, so I made the statement that I can't get pregnant. We all agree that I cannot get pregnant, right? So why is that? Does anyone want to take a crack at it? Someone tell me why I can't get pregnant.
Because you're not equipped to?
Yeah, there we go, because I'm a guy. Now, how do we prove this by contradiction? Let's make the statement first. There we go. So how do we prove this by contradiction? We have to assume that I can get pregnant. We assume that I can get pregnant. Now we write down some facts. clearly I'm a guy. So let's say fact 1. I'm a guy. And fact 2, we can say that only girls can get pregnant. So let's write that down. Only females can become pregnant. So we use fact 2. Assume that I can get pregnant. Only females can get pregnant. So let's write that down. Okay, so I can get pregnant implies, so that's an implication symbol. I can get pregnant implies that I'm a female. And that's a clear contradiction of the first fact. So that's a contradiction. And because that's a contradiction, we can say that I can't get pregnant. That's very simply how you do a proof by contradiction. So what did we do? We made a statement, and we contradicted it. So we can write down the steps of proof by contradiction. First step would be to contradict the statement that we're trying to prove. Next step would be to put down some facts. And then we have to contradict one of the fundamental facts. And after that, we just simply conclude it. And I'm running out of time, so let's quickly just do the proof. Can I put it here? Yeah, okay. Okay, so let's say radical 2 is an irrational number. How do we do the proof? Let's assume not. Let's assume not. So that means this implies radical 2 can equal m over n, such that m and n are integers in lowest form. So we do simple algebra. N radical 2 is going to equal m. We square both sides. 2n squared equals m squared. This means that m squared has to be even. If it's even, we can write it down like this. M squared is even. This means m is even. It's a fundamental fact. So m is going to equal, say, 2p. We can write it down like that. And then we plug it back in. So we take this 2p, we plug it back in here. We get 2n squared is going to equal 4p squared. The 2 and the 4 cancel to produce a 2 here. So let's just write that explicitly. N squared equals 2p squared. Now this implies, I don't know if you can see this because of this. So this implies that n must be even by the previous argument. And that's a contradiction. Because we said that m and n have to be in lowest form. Let's just write that down. So if n and m are even, they both are divisible by 2, that's a contradiction. So radical 2 must be an irrational number. So I believe that's my time, and thanks.